Welcome to everybody. Welcome to my YouTube channel, MadLab. Yeah, today we are going to talk about conic section. Okay, so let us first start by having a definition. Okay, a conic section is a part of a point which moves so that its distance from a fixed point is in constant ratio to its distance from a fixed line. Okay, where the fixed point is the focus, the fixed line is the directrix, and the constant ratio is the eccentricity. Okay. Now the eccentricity is denoted as E, the focus is denoted as F, and the directrix as G. Okay, so our eccentricity is small e, focus capital F, and directrix capital G. Now we need to note that in conic section we have three main classes. Okay, and the three main classes depends on the value of the eccentricity E. So when E is less than 1, the conic section is an ellipse. 2. When E is equal to 1, the conic section is a parabola. 3. When E is greater than 1, the conic section is a hyperbola. Also, one thing to note, when E equals to 0, then the conic is a circle. Yes, a circle is a conic section. Okay. Let us now pass to the first type that we're going to study today. That is the ellipse. Okay. So, let us have the definition. The part of a point which moves so that the sum of its distances from two fixed points is constant is an ellipse. Do you get that? That is, the part of a point which moves so that the sum of its distances from two fixed points is constant is an ellipse. Okay? Now this is a general view of an ellipse. This main axis here is our coordinate axis. This line here is the line of the directrix. Okay, denoted as capital G. So this dot here is the point actually where the directrix is falling. You just draw a line, okay, on that point. So this other point here is our vertices. This is our focus. This is the particular point, that distance that we're always talking about. This is the distance. Okay, we have that. Now these points are also gotten from calculation and all the rest, and this is how the conic section looks like. Okay, so now the general form of an ellipse is with center 0, 0 is x squared all over a squared plus y squared all over b squared equals to 1. For this case, the center is 0, 0. It means the ellipse have the center 0, 0, just like in this case. Now, the general form of an ellipse with center m, n, m, okay, is denoted as this. We have x minus n all that to the power 2 all over a squared plus y minus m all that to the power 2 all over b squared equal to 1, where n and m is the center. Okay, so now let's pass to steps. Okay, step that will help us to sketch an ellipse. So first we have to determine the measure axis of the ellipse by comparing the value of a squared and b squared. Okay, so we need to compare the values of a squared and b squared to see where the conic section will lie. Okay, for this particular example or this diagram, you can already see there's line on the x-axis. Okay, so for the first condition, if a squared is greater than b squared, then the ellipse lie mainly on the x-axis. Okay, we are going to call it equation A. Now, if b squared is greater than a squared, then the ellipse lies mainly on the y-axis. Okay, so for this other diagram here, the case here is the first case, because a squared here was greater than b squared. That's why it's lying now on the x-axis. Okay, so let's now shoot directly to some derivations in the first cases. Okay, so for case A, things we need to know. The equation of the eccentricity is given by b squared equals to a squared into 1 minus e squared. Okay, so that is it. Here is when e is less than 1. Okay, yes, we get that. Now, the foci f1 and f2 are gotten from the equation f equals to x minus n equals to plus or minus ae, where e is the eccentricity and a is the value of a. Because here we have a squared, from the general form, you just do the square root to get a. And you have y minus m to be equals to 0. So this is the general form. From this now, we can get f1 to be equals to n plus ae. That is n is one part of the center and m is the other part, okay? And you have n plus ae and m. And for f2 you have n minus ae and m. So these are the two foci, okay? Now the directrices are gotten by solving the equation g equals to x minus n, g, yeah, equals to x minus n equal to plus or minus a on e, and y minus m equals to 0, okay, for the first case. Yeah. So now this will imply that what? This will imply that the first directrix d1 is n plus a over e m, and the other one d2 is n minus a over e m. Okay, now for the vertices, okay, the vertices are gotten by solving the equation v equals to this: x minus n equals to plus or minus a, and y minus m equals to 0, simply. So this will imply that our v1 equals to n plus a and m, and our point v2 equals to n minus a m. Yes, where the center c is n and m. Straight. Now let us have the second case, case b. Okay, and for our case b, we had that b squared was greater than a squared. So for that now, the equation of the eccentricity is now given by a squared equals to b squared into 1 minus e squared. Very simple, okay? For case a is b squared equals to a squared minus 1 over e squared. The second case is a squared equals to b squared into 1 minus e squared. Now the foci is gotten from the foci f1 and f2 are gotten from the equation f equals to this. Now for this case, there's one thing you need to note. For case a, it was x minus n equals to plus or minus ae. Now for case b, it will be x minus n instead equal to 0, and y minus m equals to plus or minus be. Okay, now on the other side, now we use the b. That is it. So now f1 will be denoted as m equals to m plus be, and f2 will be n and n minus be. Now the directrices are gotten by solving the equation g equals to this. Still the same thing, you just reverse everything. Now it's x minus n equals to 0, and y minus m equals to plus or minus b on e. We get g1 and g2. g1 n equals n and m plus b on e, and g2 n and m minus b on e. Okay, now the vertices are gotten by solving the equation v. Still the same thing, but you have now to reverse. We have now x minus 1, x minus n equals to 0, y minus m equals to plus or minus b. Okay, for this case was x minus n equals to plus or minus a. Now for the first vertices, we have n and m plus b, and for the second one we have n and n minus b, where the center is c, n and m as usual for the two cases. Okay, now having that, I think we can now take a rapid example, okay, to solve and see how it comes about or how we work it out. Now the question is, determine the nature of the conic section of this 25x squared plus 9y squared minus 100x squared minus 100x plus 18y minus 16 equals to 0, and sketch it. Okay, so for the solution, this one thing you need to note, okay, this particular equation here, to know which form it is, we need to complete the square. Okay, we need to solve it by completing the square. So this is the equation. Now how to complete the square in this case? In this case here, you have an equation in terms of x and y. You have first of all to group like terms. Okay, like in this case, you have group x and x together, y and y together, and the constant alone. Now there's one thing also you need to note. Just like when you want to complete the square of a normal quadratic, the denominator, the coefficient of x squared must be 1. Okay, since here is 25, we factor out the 25. Knowing that now x now is having its own another x, so the x are working together, so you also factor out 25 from this 100x, and you're going to get 4x. So this for the first part. Same for y. You simplify the denominator until the coefficient of y squared until you get 1. You factor out the 9, and the other y here, you get 2. Okay, so we have y squared minus 2y. Okay, so we have this minus 116 and 16 equals to 0. Now I think there's an error here. Yes, this sign is supposed to be plus, please, sorry. Okay, it's 9y squared plus 18y. You factor out 9. Okay, we instead have a plus here, sorry. So now the second step now is what? You now have to take half the coefficient of x, okay, as in normal quadratic. Take half the coefficient of x and you add it in both sides of the equation, and you add the square of it in both sides of the equation. Okay, so for that now we complete the square again. For this other part, we take half of 4, we have 2, we square the 2. Now we now get a factor like x squared minus 2 squared. You now factor out the square, you get x minus 2 squared. Now you know that this thing is just like, since it's like a quadratic, you have added two factors. Okay, it's very long, so you have added another factor. There's another factor, negative 2 squared. You now open it, you have a 4. You multiply the 4 by 25, you have this 100. Okay, this is where this 100 originates from. And the other to this other 25 just remain here. You multiply the first bracket. Okay, same for y. As you can see, you take half the coefficient of y. Yes, you take half of it, you square it, and you add it, you get y plus 1 other squared, and the other coefficient will be 1 squared. Okay, it will be negative, it will be negative 1 other squared. It will be 1 squared minus 1 other squared. Okay, when you have that, you have now negative 1. You take 9 times negative 1, you get this. Now you have to add now or group all those constants together and send to the other side of the equation. So you're going to get what, 25 into x minus 2 all that squared plus 9 into y minus 1 all that squared equals to 225. Now after this, you just have to divide both sides by 225 and you have this. So you have 1 on 9 for the first case, 25 divided by 225, you have 1 on 9. And for the second case, 9 divided by 225, you have 25. So we can now see that the final equation is x minus 2 all that squared all over 9 plus plus 1 y plus 1 all over all that squared all over 25 equals to 1. Therefore, this one resembles this type of an equation with center 2 and negative 1. Okay, as we can see. So the conic section is an ellipse with a squared equals to 9 and b squared equals to 25. We can already know that what, that b squared is greater than a squared. Are we okay? Yes. Now when b squared is greater than a squared, we have to talk about our case b. Yes, exactly. So the equation of the eccentricity now for case b is given by a squared equals to b squared into 1 minus e squared. Replacing the value of b squared and a squared, simplifying, you are going to get e to be equal to 4 on 5. Noting that our center is 2 and negative 1. Are we okay? Yes, I hope so. Now we go to find the foci. Okay, we have f1 denoted given by this and f2 given by this. We replace the value of n, m, and b and e. Okay, note b now will be the square root of b squared. Okay, yes, the square root of b squared, you're going to get the square root of b squared will be 5. Okay, you replace it here, you multiply by the eccentricity, and you're going to have all what we have here. So this f1 and this f2, just applying the formula. Okay, the more you apply, the more you retain. Okay, the standard form, so they will not change. Now our g1 is given by this also. We replace the value of m, n, b, and e. We still get this. Now the other point now is for the vertices. Okay, now for the vertices, we have the general form of the vertices. We have v1 equals to this and v2 equals to that. We just replace the value of n, m, and b only, and we are going to get our two vertices. Voila. Now with this, now noting also that our ellipse lies mainly on the y-axis. Since the relation is b squared is greater than a squared, we now have sufficient information to sketch our curve. Okay, to sketch our ellipse. Now let's pass to the sketching. It's very easy to sketch. Okay, once you have already all the given points. So we have our eccentricity, our center, our foci, our directrices, and vertices. Now the graph, this is how the diagram will look like at the end. You just have to scale well your coordinate axis and you plot exactly each point. You put each point where they are supposed to be. Note the edges of the ellipse of this side will be the vertices. So here is our v1 and here is our v2. Let us see it clearly here. Okay, now our directrices are this one. Since the equation since the ellipse lies mainly on the y-axis, our directrices are normally they're only just small a point. Okay, but now you just draw a horizontal line, just like it's showing the direction in which the ellipse will be pointing. This is the one for up, this is the d1 and this is d2. Okay, we have this. Now these are our vertices, v1, 2, and 4, v2, 2 and negative 6, and we have our f1 and f2. Then we have our center, 2 and negative 1. Okay, it's very easy to plot. Now things to note: how do we now know how uh, how this length will look like? Okay, we can see that this length is 1, 2, 3 units starting from the center. Now this 3 units is gotten by the value of a. Okay, you have a squared equals to 9, so you do the square root of 9, you have 3. So you'll be moving 3 units on this side and 3 units on this side starting from the center, and you're going to have this. Okay, so having all your data or all your points well done, you just have to plot your ellipse, you sketch it, and it comes out good. So I thank you all guys for watching. Please like, comment, and share, and subscribe to my YouTube channel. Okay, because the next video that I will upload will be the one for the parabola and the hyperbola. Okay, so please follow. Okay, share the video, please. You can leave comments. Okay, thank you. So see you in the next video.